Some problems and solutions of congruent triangles. Exercise 7.3. Question number 1. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, so that number 1. Triangle ABD and triangle ACD are congruent. Solution. In triangle ABD and triangle ACD, we have AB is equal to AC given, BD is equal to CD given, AD is equal to AD common. So triangle ABD and triangle ACD are congruent by SSS congruence rule proved. I have just proved the first part of question number 1, and now the second part. Second part is so that triangle ABP and triangle ACP are congruent. Solution. In triangle ABP and triangle ACP, we have AB is equal to AC given, angle BAP is equal to angle CAP by CPCT. Just I have proved triangle ABD and ACD are congruent. So from that proof by CPCT, angle BAP is equal to angle CAP. AP is equal to AP common. So by SAS congruence rule, triangle ABP and triangle ACP are congruent proved. Now third part of question number 1. Show that AP bisects angle A as well as angle D. Solution. Triangle ABP and triangle ACP are congruent. We have just proved in a second part of this question. So angle BAP is equal to angle CAP. Therefore AP bisects angle A. This is equation number 1. Now triangle ABD and triangle ADC are congruent from first part of question number 1. I have proved. So proved above in 1. So angle ADB is equal to angle ADC by CPCT, or 180 degree minus angle ADB is equal to 180 degree minus angle ADC. So angle BDP is equal to angle CDP. Therefore AP bisects angle D. Equation number 2. From 1 and 2, AP bisects angle A as well as angle D proved. Fourth part of question number 1. Fourth, show that AP is perpendicular bisector of BC. Solution. Since triangle ABP and triangle ACP are congruent, so angle BPA is equal to angle CPA by CPCT. Angle BPA plus angle CPA is equal to 180 degree linear pair. 2 angle BPA is equal to 180 degree, or BPA is equal to 90 degree. Since BP is equal to CP, therefore AP is perpendicular bisector of BC proved. Question number 2. AD is an altitude of an isosceles triangle ABC in which AB is equal to AC, show that number 1 AD bisects BC, number 2 AD bisects angle A. In triangle ABD and triangle ACD, we have angle ADB is equal to angle ADC is equal to 90 degree, because AD is altitude of triangle ABC. AB is equal to AC given, AD is equal to AD common. By RHS congruence rule, triangle ABD and triangle ACD are congruent. So BD is equal to CD by CPCT. Hence, AD bisects BC proved. Since triangle ABD and triangle ACD are congruent, I have just proved in one of this question, solution of this question. So angle BAD is equal to angle CAD. Hence, AD bisects angle A proved. Two sides AB and BC and median AM of one triangle ABC are respectively equal to sides PQ and QR and a median PN of triangle PQR, so that triangle ABM and triangle PQN are congruent, number 1, and number 2 is triangle ABC and triangle PQR are congruent. Solution 1. In triangle ABM and triangle PQN, we have AM is equal to PN, AB is equal to PQ given. Since BC is equal to QR given, therefore half of BC is equal to half of QR. So BM is equal to QN. By SSS congruence rule, triangle ABM and triangle PQN are congruent proved. Solution 2. We have to prove triangle ABC and triangle PQR are congruent. So in triangle ABC and triangle PQR, we have AB is equal to PQ given, angle ABC is equal to angle PQR proved in first part of this question, that is proved in 1. BC is equal to QR given. Therefore, by SAS congruence rule, triangle ABC and triangle PQR are congruent proved. Question number 4. BE and CF are two altitudes of a triangle ABC. Using RHS congruence rule, prove that the triangle ABC is isosceles. Solution. We have to prove triangle ABC is an isosceles triangle. At first, we have to prove triangle BEC and triangle CFB are congruent. Then we can prove angle B equal to angle C, and then we can prove the given triangle is isosceles triangle. So BE and CF are altitude of triangle ABC. Angle BEC is equal to angle CFB, that is 90 degree. Now in triangle BEC and CFB, we have BC is equal to BC, that is hypotenuse, and BE is equal to CF, that is one side of two triangles. So by RHS congruence rule, triangle BEC and triangle CFB are congruent. So angle BCE is equal to angle CBF CPCT by CPCT. Now in triangle ABC, angle B is equal to angle C. Since sides opposite to equal angles are equal, therefore AB is equal to AC. Hence, triangle ABC is an isosceles triangle proved. Question number 5. ABC is an isosceles triangle with AB is equal to AC. Draw AP perpendicular to BC to show that angle B is equal to angle C. Here ABC is an isosceles triangle with AB is equal to AC. Draw AP perpendicular to BC. We have to prove that angle B is equal to angle C. In triangle ABP and triangle ACP, we have AB is equal to AC, angle APB is equal to angle APC is equal to 90 degree, AB is equal to AP, triangle ABP congruence to ACP by RHS congruence rule. Also angle B is equal to angle C by CPCT proved. Thank you.